All right, Christoph, welcome to the show. You are from Project Threefold and you are rebuilding how the internet works. You're truly changing the backbone of our internet infrastructure. So, welcome to the show and please tell us a bit about yourself.
Hi, Ivan. Thanks you for inviting me to your show. So my name is Christoph. I'm, let's say, a nerd engineer. Since I'm 9, I'm like programming, and that was still like the Commodore 64, small little computer. And then I was lucky that when the internet started, I was one of the first guys being part of the internet. And I grew with the internet. And today we are in a spot that we see that the internet is having some issues. And basically I have a company which tries to do something about it.
So what would you say is the biggest issue? Is it just the speed? Is it the routing? Is it the addressing? What is the main issue, would you say, with the internet right now?
Well, we identified a couple of issues, but I think we can start with the fact that when the internet started, it was really a sort of like hippie movement. Everyone connected hardware and networks, and it all together was actually a very beautiful interconnected mesh. And it gave a lot of great hope for the future. And if today we look, we kind of lost that a little bit. Today we have these massive big data centers where everything comes from. And these data centers are in few locations. So today, less than 20 companies in the world own actually more than 80% of the internet capacity. And when I say internet capacity, I don't mean the network. I mean the compute, the storage, actually where our applications and our information is. And this is not what it should be, right? And it has lots of side effects because today, in the way how we use tech and how we use our phone, in a way we became like a cyborg. We use it every day, we're very close to it, but the data is not ours. It lives somewhere in the cloud in one of these big data centers owned by some centralized companies, and this obviously is not okay. The second thing has to do with energy usage. Today, these data centers use 10% of the world's electricity, 10%. And the internet needs to grow like 3, 4, 5 times, they're saying. But that's huge, right? So you can imagine we would have to use 20, 30, 40% of the electricity production, and that would be absolutely insane. So we need a new way how to build out this data center. And the third but not least, inequality. Today, half of the world does not have equal access to information, education, and the internet. So it still needs to go to many more places. But because of the way how it's constructed, it's not possible. It's too centralized and it's too slow, and it's also very vulnerable. If today you cut some cables, you literally lose your internet.
Yeah, I mean, it's very interesting topic because I've seen this explanatory tutorials online where they talk about that Latin America is basically connected with a cord to the full internet, and if that cord from the US is broken, all connection is lost. But it seems that you're both talking about software aspects and hardware aspects of the internet and how it's structured. And you also say we use a lot of energy, and you say that centralization and data centers are a problem, but I think to most people when they hear that do you have these big data centers, it seems like it should be more efficient to have a big data center that is optimized and you have a bunch of economy of scale benefits than to have it more in a decentralized way. So do you agree with that or disagree?
I disagree, because data centers by themselves can do things rather efficient, but the IT industry became very non-efficient. If today you look at the way how we use hardware, I mentioned before, my first computer was a Commodore 64, 64 kilobyte of memory. And that thing was pretty much doing everything we need today, right? Today, my machine is literally 10 to 20,000 times more powerful. But did it got 10 or 20,000 times more features? Of course not. So where did all of that go? We lost all of that. So basically we lost the ability for a big part, how to be efficient with hardware and how to put it together. And because we exist today on the internet so many times, I mean, for every service you use, you exist as an individual person, as like you have an avatar, if you want, somewhere with a big company. And every time you exist, you consume a lot of resource. And this is simply not the right way how to do this. So we need a new paradigm where you are put in the center of your digital life. And you are the only one who has access to your information, your applications, your digital life, and from out of which you create circles and you communicate with the people around you. So it needs to be built in a very different way. And we can prove today, I know a lot of people say, how can that be done? But for certain workloads, we can literally save 1,000 times in energy. 1,000 times, not 2 times, 3 times, 1,000 times. And this is not because of, oh, you're just a little bit more efficient in a data center. No, this is because of fundamentally changing the way how we store data or how we work with applications or how we communicate. And as such, we can be so much more efficient. So these data centers by themselves are okay-ish. Only the way how they approach the problem, it's very brute force. It's like millions of servers being put together where we all are part of, and it's very brute force. And that can be done in a much more intelligent way.
Interesting, and it also on the user machines as well. I mean, we sent a device to the moon decades ago, and now we need gigabytes and gigabytes of RAM to just run a browser. That's insane. Exactly. And that's another way of looking at it. So I get the point, and what you are basically saying is that it's too much duplication, that I have an account in this service, for example, in Google, I have an account in Facebook, so there's a lot of data duplication. So
data, applications, databases, everything actually. Yes, that's one of the issues.
So looking at all of this, what kind of solution do you guys bring with Threefold? How do you connect all of this and solve it?
Well, look, this world has some challenges, right? I mean, and more people now get aware that things need to change. And we believe that change in this world it needs to come from all of us. It is not going to come from yet another government or some person saying, oh, I'm the new hero. No, it needs to come from all of us, right? So we need a new movement, if you want, a digital movement where all of us together create this internet. Just like how it was intended in the beginning. It should be not some new company saying, oh, you know what, you don't like Facebook anymore. Oh, here you have a new Facebook. Now come to me because I'm the better new Facebook. Yeah, but no, that's not what we need. What we need is that we all together can say, you know what, let's all together build a new internet, and we all own that internet. And the cables are still needed, of course, but anything but the cables. So how can we do that? So we can do that all together, and we call the people who extend the network farmers. It's a little bit like Bitcoin, if you want. They call it a miner. We decided to call it a farmer because we don't want to burn energy for nothing. So basically, a farmer is a person who says, I want to expand the internet. They buy a hardware box, any piece of hardware. They connect it to the existing cables. They power it on. They download our software. They put it on there. It's like a new operating system. And now this box will add compute, storage, and networking capabilities to the existing internet. And that way, all of us together, we can keep on expanding this internet and grow it. Now, all of the apps now are no longer in decentralized data centers. Literally, well, actually, it's kind of funny, but I have a small box next to me. Its box is that size or even smaller if you want. Or of course, you can have very big boxes too, which you put in data centers, but all of them together now make this new internet substrate or this new internet backbone where everything gets interconnected, giving capacity to everyone in the world. And as such, all together, we can extend it so that, as an example, in Africa, they have more capacity, or South America, and we can do it much more equally. The price can be much lower. And by doing the way how we do it, we also consume a lot less energy. So it's a very different design. And we as a person, okay, you can run any app on this. So anything which runs on Linux can run in a different way, so packaged onto this new network of capacity. But eventually, we can all have our own avatar, our own digital twin. And that's basically like you would have, think about it like a little bot, which just runs there. And it's your own digital life, and it has everything about you. But you're the only one controlling your digital twin. So it has your data, it has your applications, it has your everything, and it lives on this network of capacity. So it's a very different architecture.
So if I'm to push back a bit, so what about the network speed? When you have a data center, everything is in one place. There is no network time that you need to wait. Also, what about heavy load calculations?
Well, today, thank you for bringing it up about the network. Today, it's really ridiculous. I'm now in Ibiza, right? And if I have a friend here a little bit further and I want to send an email to him, what happens? My email goes to America, to a big data center. It gets stored there in a huge scale out sort of database, right? Then that guy does the exact same thing before he can download it. So network-wise, this is absolutely ridiculous. While if we would do this on this island, it would be 0.1 milliseconds, and my message would go from we call it the tree, but from my digital twin to his digital twin, and it would go incredibly fast. So network-wise, actually, the idea of what we're having is this works much faster than how they do it today. Because the fact that I need these network connections in these data centers is only useful as long as you are in that one silo. So you are in your mail system or your chat system, but not like as a normal person, 99% of what you do is with people around you, right? It's people in your village, it's people in your country. So why would everything have to go back to some centralized locations? And for every separate application, you need to do that. That makes it super inefficient, but it also makes it very cumbersome. If today you want to do something, we became so app-centric. It's WhatsApp, it's Telegram, it's SMS, it's email, right? And you have to remember, what did they send to who? What did they use? What is that person
in
using?
what app? Yeah,
it's a mess. So you don't want that. And what we suggest, you get a very different way of looking at this. Like, I don't have to know any of this. I just talk to my own digital twin and I ask my digital twin to do something, and it all kind of magically happens, right? And it goes much faster, using a lot less energy than before, because you don't need all of that.
So in terms of communication, let's say I have my device where I have my digital avatar and he wants to send something to you, some message to your avatar. What kind of networking protocol are we gonna use for that?
Standard internet, TCP. But it will stay local. Imagine you are, especially if you are in areas like we are in areas with good internet connectivity. But if you are in Africa or you're in South America, their internet is typically very expensive and not that reliable. So, and they don't have local capacity. There is no internet capacity there. It means that anything they do, they need to go over overloaded fiber connections or often even satellite before they reach a point where they can sort of connect to a centralized service. And that makes it all very slow and very cumbersome and very expensive for them as well. But if you're already in Africa and you send something from A to B, why would it first have to go to Europe or America? There is no point. It all needs to stay local, and then it can go much faster.
And if you look at nature, it does make sense, whether it's the brain that is decentralized computation or whether it's mushrooms, fungi, mycelium, networks underground. It's all decentralized intelligence. So it makes sense that long term we should move towards that to achieve more compute, more intelligence as human race. So the computation happens locally, as you say. Yes, but what kind of software advanced do we need to make that happen? Because, I mean, obviously, if you look at how servers are structured, how internet is structured, it's all built around this, server-client model. Here, you're making it peer-to-peer. So more practically, what kind of software will people run on these devices? You mentioned Linux. Is it some kind of tweaked version for making this work? What is the software level?
Yeah, well, a couple of questions here. I'll try and break them apart.
Yeah.
One is, what is running? That I'll do in a sec. And then secondly, how do people use it? Because already today, it's already very big. We have active in the field it's between 40 and 80 million gigabytes of storage. It's already there. We have more than 18,000 CPU cores there. So there's a lot of storage already there. Actually, today we have more capacity on the grid we have created than all of the blockchain projects together, which is already a lot, I would say. Now, today there are two parts to what we do. There is the capacity part, which is just people who need to put their application somewhere, right? Because there are a zillion of existing applications. And today the internet is growing fast because of Internet of Things, because of artificial intelligence, because of security cameras, because of self-driving cars, right? Name it, it's really growing fast. But most of these workloads want you to be close to those workloads, like gaming. Gaming only really works very well, or virtual reality, if the latency between you and the workload where your application is not far. If you do virtual reality and it goes interactive with some peers and there is like a continent in between, it's going to be very sluggish. So there are a lot of workloads which need to be close to you. Well, that's the first thing which we do, which is we allow anyone in the world to basically put their existing apps. We support Docker, Kubernetes, all of S3, all of these existing standards. So people can, without changing much, run what they already have today, much more closer to where the people are. That's the first stage where we are right now. We have the second generation.
When you say apps, do you mean backend apps that I can take my thing from AWS, like you mentioned, and all APIs will be compatible with your version? All right.
So today you have standard, it's like Docker and Kubernetes, which is used a lot. So you can literally do the exact same thing and run it at the edge now, which has a couple of benefits for you as a developer or a software vendor or a service provider. It will be much faster because it will be closer to where your user is. It will be much more cost effective because of our technology. We managed to make it much better. It will be more secure as well. We have some very cool layer about how we can deploy stuff in such a way that a hacker cannot get access to it. So you have a number of benefits as a user of that system to do that, right? That's today. And then later we have more this digital twin coming in. But that's for later, that's not for today, where together with the community, we work on how can we reinvent our digital future life. We have already a lot. We have like Office and Mail and lots of things already done on there. And that's just web interfaces. So people, web developers can just using their existing web tools, but they do it against another backend. So we have these two layers independent from each other, right?
So interesting. So as a developer, let's say I have my backend on AWS. There I have my my endpoint URL. So let's say I want to switch to this model, and in this model it means that my software will be running on all of these small nodes across the world, and depending on where the user is, that's the node that my frontend is going to call and interact. So who is doing this load balancing? Because the frontend needs to choose what device to speak to. So
true, but that's all built. Just like how you do it on a global, with existing data centers too. You have global load balancing, your DNS, all of these things do exist. We do the same on our network. You can do exactly the same. So basically it would feel very familiar for everyone coming from these data centers. And we also don't see it as like an all or nothing kind of thing. It's not like, oh, people need to move away from Amazon. No, sure not. If they're happy, they can stay. It's more like there's a massive amount of growth required, and many countries don't have capacity yet. So just having the ability to put your IT workloads, your server workloads, where your user is, just seems to make a lot of sense, right? Also, you said small boxes. Indeed, I showed you small box, but most of our existing capacity even still runs in data centers, because there are a lot of guys who put the same technology of what we have in the data center, right? So it's not like we are against the data center. They just put it there because they happen to have good connectivity or it's close to a certain region. But what it does is that it allows anyone in the world to become a farmer. You can be a small farmer at home. You can be a commercial farmer using a data center, but you're still expanding this network of capacity everywhere in the world without even the need for a data center, but you can still use it. And that makes it very different, right? And to do that, because there was another question you asked, okay, what is it? Is it some sort of modified Linux? Well, you're very close, actually. So we took the Linux kernel, but that's the only thing we took, Linux kernel and Linux modules, and then we had to rebuild everything around that. So we have our own storage layer, virtual file system, our own network layer. We had to do many, many things basically on top of this Linux kernel, so that we can, from the start, it has no shell. It has no server interface. It's really very low level operating system, very close to the hardware with very specific algorithms, which allow us to use the hardware much better. Like for storage, we will use 10 times less energy, which is a big saving. And also we use a lot less disks. And this allows us to be much more efficient. And on top of this, you can run Linux, anything you can run on Linux, you can run on this as well, because we use the Linux kernel, but that's where it stops. We had to reinvent everything else around that. And there is some like blockchain layer on top. We call it a smart contract for IT. So basically, if you want something, you basically can define your workload, you register it in a sort of blockchain, and then one of the nodes in the world, it can be millions of them, and you can even define how will pick up the workload, will bring it live, but in such a way that a hacker or no one else can ever interfere with it.
And as a farmer, what do I get paid then? Because I guess you're rewarded for being a farmer.
Yes, it's like Bitcoin. If you farm, you get, as long as you keep your hardware connected, you mine or farm tokens, right? Just like in Bitcoin, there is a difficulty level. So as you farm, the difficulty level becomes more, because we have a maximum of 4 billion tokens. So basically, as you get closer to the 4 billion tokens, the difficulty level will go up, so the farming becomes less interesting. But as a farmer, you also get what we call cultivation, because you provide also usable capacity, storage network and compute capacity. And everyone using your storage or network capacity or compute capacity will transfer their tokens to you. So you as a farmer make money twice. You make money by farming, connecting the box, and you make money by providing the capacity to the network, so people need to pay you for using that capacity. And as the network grows, you will get more from farming because more and more people use it. You get more and more from cultivating, so from selling capacity, and less from farming because the difficulty level goes up. And that sort of balances each other out.
Interesting. So I think we've discussed the most important things. Is there anything else that you would like to add before we wrap this interview up?
Well, look, I think it's important for the world to have this new internet because this is not our company, right? It's not like we're building a new Google or something. But I think all together, participating on a new internet and extending it and giving room for many projects to live on top of this is just very important. We have already like more than 20 blockchain projects moving their stuff on top of this network. And what we would like to ask for is that people who hear this message basically say, look, why don't we extend this internet together? Why don't we become a part of this new internet? And as such, make us more free digital citizens.
Yeah, that's very important. And I really like the mindset. And I think that we covered the most important questions that people might have. For example, the thing with data centers, efficiency. And I think you've thought through this project. So that's good to hear. That being said, Christoph, thank you so much for being on the show. And guys, please check out the links in the description. If you are interested, get the hardware. So you are being a farmer. And you can get rewarded by just farming and also then by cultivating, by offering your capacity. Christoph, thanks a lot, and we'll be in touch. Good luck, guys.